This is question 2 of the homework. It's asking us what value of maximum force will give us an impulse of 7.2 Newton seconds. In order to solve this question, we first have to know that according to Newton's second law, a force acting on an object is equal to the rate in which the momentum changes over time. We also know that a change in momentum is equal to the impulse, so we can rewrite this as the force is equal to impulse over change in time. So what we can do to answer this question is solve for the area under this force time curve. This will be equal to our impulse because, the sum of each force times change in time will be equal to the impulse according to Newton's second law. So that means that the integral, or the area under this curve, is going to be equal to our impulse. So solve for the area. I can see that this is a trapezoid. It's the easiest way I think of doing this. So we're going to set this equation up. Our impulse is equal to the area under the curve. So here we have, let's use a different color. Here we have 4 milliseconds, and here we have 8 milliseconds. So we can do 4 plus 8 divided by 2 times our F max. Okay. And then we can plug in our given impulse, which is 7.2. So 7.2 equals, we can solve this really quick, that's equal to 6 milliseconds times F max. Now we can also make this 7.2 in seconds. So now we can just solve for F max. Divide by 6 milliseconds. So 7.2 Newton seconds divided by 6 milliseconds equals our F max. Here we can see that there's 2 different units. So we have to convert this millisecond into seconds, so we can do that quickly here. There's 1,000 milliseconds in 1 second. This allows us to cancel everything out evenly, and we're left with we can put that in the calculator now, which is 1,200. Let me do it quickly. 7.2 divided by 6 times 1,000, is 1,200 newtons. So this makes sense because we can see that the units for force is in newtons, so we can confirm that that looks correct. And it is also correct on the homework, so